Hello everyone, I am Kiran Kumar from the Nature of Physics. Today topic is most important LAQ from the wave motion, that is stationary wave or standing wave. Step by step clearly I am going to explain with diagram and derivation. Please do like and subscribe our channel Nature of Physics. Due to the like, the video will reach to the number of students. So that two progressive waves we are considering. These two progressive waves traveling in opposite direction with same amplitude and the frequency, they are overlapped to each other, that is superimposed to each other. Then the resultant wave form the node and antinode, student. So that stationary waves form. See, two progressive waves of same amplitude is same, we can observe in the diagram, and frequency also same, traveling along a same straight line. This is a same straight line in opposite direction or superimpose a stationary wave is formed, student. Okay, so but here we can notice node and antinodes are alternately formed. For this, the conditions to form the stationary wave or standing wave is the progressive wave. How many progressive waves? Two progressive waves with same amplitude and frequency. How we will get? So one wave is traveling in forward direction, it get reflected at the rigid support, so that both waves travel in opposite direction, superimposed to each other, so that the resultant wave is called, what is that, student? Standing waves or stationary waves. For this we are considering a string is fixed between the two rigid supports. So this is the string is fixed between the two rigid supports and it is excited, means so the string is just pull upward direction and leave it, so that the waves is created. The waves in a stretched string is transverse stationary waves form, student. What are that? Transverse stationary waves. Okay, so it is excited, means string is excited perpendicular to its length, and transfer wave get reflected at the rigid support to form transverse stationary wave, student. To form, what is that? Transverse stationary waves in a stretched string. So y1 is the forward wave, student. Notice that this blue color representing, see, and next the wave get reflected at the rigid support. So this is the reflected wave, but reflected wave is in opposite direction, that's why taken here negative sign, student. Okay, so that here two type of amplitudes we will get. One is node and another one is antinode, student. Node area, there is a amplitude is equal to 0, so 0 amplitude, that is mean position, and antinode area an representing maximum amplitude from the mean position. So this is straight line is mean position. Okay, so now here amplitude is maximum for the antinode, here amplitude is minimum for the node. So next I am going to give the derivation for the formation of stationary waves in stretched string, equation of the stretched string, formation of standing waves, and also node and antinode positions with clear derivation. Okay, student, see, now this is the string, some length is L, fixed between the two rigid supports due to small vertical jerk perpendicular to the length, so that a wave is created, that is transfer wave. Transfer wave get reflected at second rigid support and it is traveling in opposite direction. Minus is clearly represented. Forward wave is taken y1 displacement, reflected wave is taken y2 displacement. So this is the equation of a progressive wave, that is y1 is equal to a sin omega t minus kx, and this is also equation y2 but in opposite direction with same amplitude, minus a sin omega t plus kx. Here minus of minus plus, because of this is forward direction is positive x-axis and this is representing negative x-axis. Okay, student, so we got the two equations. two progressive equations, displacement equations, so that next law of superposition principle, so that the resultant displacement equation y is equal to y1 plus y2 student. So y1 I am replacing a sin omega t minus kx, and y2 value is minus a sin omega t plus kx. Okay, so sin a plus b formula here. Now sin a minus b, step by step I will replace the value y, which is equal to a sin omega t cos kx minus cos omega t sin kx. See student, here minus, here I am writing this, okay, a common, so sin omega t cos kx plus cos omega t sin kx. See student, a multiplying here, y which is equal to a sin omega t cos kx minus a cos omega t sin kx, and this minus is multiplying here, minus a sin omega t cos kx. So here minus a cos omega t sin kx. So this positive value and this negative value should be get cancelled. See, continuation derivation for this resultant displacement equation, that is y which is equal to minus, so 2a, this is sin kx cos omega t I got. So this is minus representing opposite direction, resultant is in opposite direction. Okay student, so take it inside the bracket since. Okay, and next the y which is equal to 2a sin kx into cos omega t, so that y which is equal to a cos omega t, this is equation of the stationary wave. So I am representing equation 1. Equation 1 represent equation of stationary wave or standing wave. Okay student, and a represent their resultant amplitude. What is a there student? A represent, that is 2a sin kx resultant amplitude. Resultant amplitude, okay, resultant amplitude of the equation of stationary wave. Okay, so that here we need to get the node position and also antinode position student. So first representing node representing letter is n student. For node there is a zero displacement. What is that? Zero displacement. Okay, and next one is antinode student, represented letter an, so that is maximum displacement of the particle from the mean position. Key points writing, and then continuation here we need to get the positions of node and antinode by the equations. So resultant amplitude for node area, resultant amplitude is equal to 0, nothing but sin kx is equal to 0 student, that is kx which is equal to n pi. So k value which is equal to 2 pi by lambda. Wait a second please. And next step also representing, that is for maximum displacement, that is sin kx which is equal to plus or minus 1, so that kx which is equal to n plus 1 by 2 into pi. Okay, the continuation derivation I will do here. Wait a second please. See, continuation step. Okay, here the zero displacement of the particle from the mean position is called, what is that, student? Node. Okay, so that sin kx is equal 0, so that kx is equal to n pi. So for node, okay, a is equal to 0, that is a sin kx is equal to 0. So sin kx is equal to 0. Okay, student, and kx which is equal to n pi, and then continuation there. So here k value is 2 pi by lambda. Okay, x as usually writing, which is equal to n pi. So pi is get cancel. I am getting here x is equal to n lambda divided by 2. Okay, student, and here n representing n which is equal to 0, 1, 2, 3 up to so on. The value is replacing, so we will get the positions, that is x is the position of the nodes. So x is equal to n0 replacing, that is lambda divided by 2 into 0. As next to second position, that is 1 lambda divided by 2. Next 2 lambda divided by 2. Next 3 lambda divided by 2 up to so on. So that I am getting 0 into anything is 0. So that x which is equal to position of the node. So first one is 0 here, 0, student, and second one is lambda divided by 2. See there, lambda divided by 2, 1 loop. Okay, and next one representing, that is lambda. So 2 get cancelled, student, that is lambda. Next one is 3 lambda divided by 2, 3 lambda divided by 2 up to so on. If you want proof, you can write, otherwise directly we can represent. So node, and it is a zero displacement from the mean position, and position of the node x is equal to 0, lambda by 2, lambda, and 3 lambda by 2. That's enough. Okay now, and next I am going to discuss about the antinode, student. For this antinode, see, again writing antinode because of here proof doing. Actually in the exam no need to write the proof. Okay, for the AP and Telangana board exam purpose only I am telling to you. Okay, so antinode an, that is amplitude is maximum, student. A is maximum. Sin kx plus is equal to plus or minus 1 is the condition. So that a max which is equal to 2a sin kx. So the value is replacing here. So we will get there a max which is equal to 2a into 1. So that here amplitude is I am getting maximum. So that continuation here, condition is sin kx is equal plus or minus 1 already taken, that is kx which is equal to n plus 1 by 2 into pi, student. K value is 2 pi by lambda into x which is equal to n plus 1 by 2 into pi. Pi is get cancel. I am getting here x which is equal to n plus 1 by 2 into lambda divided by 2, student. See there, the values here, n is equal to how much? N is equal to 0, 1, 2, 3 up to so on, like this, replacing there. Continuation we will get here n is equal to 0, so that x which is equal to lambda divided by 4. And next n is equal to 1, student, that is 3 divided by 2. Okay, so 1 plus 1 by 2 is 3 by 2 only. 3 by 2 into lambda by 2, that is equal to 3 lambda by 2. Next 5 lambda by 2 up to so on, the values we will get that is representing the position of the antinode. See this here, antinode position lambda by 4. Next antinode position is 3 lambda by 4. Next antinode position is 5 lambda by 4. Actually, I said you already, proof is not necessary. You can write directly node positions and antinode position, write these equations without any proof. Okay. Yes, student. Fundamental frequency of the stretched string. For this, considering a string of length is L between the two rigid support, due to the small vertical jerk on the string, a forward transfer wave created and it get reflected at the second rigid support, so that the wave is get reflected in opposite direction, so that only one loop will be formed, that is give the fundamental frequency of the stretched string. Okay, student, what is the fundamental frequency? The minimum frequency with which stationary waves form. The minimum frequency with which stationary waves form is called fundamental frequency. Minimum frequency, only one loop formed, so that length of the string for one loop is wavelength lambda divided by 2. So directly written, L is equal to lambda divided by 2. So length of the string here L which is equal to lambda divided by 2 with respect to wavelength for one loop, lambda divided by 2, already clearly given in the diagram. See student here, so one loop give the lambda by 2. Okay, now two loops give what is that, student? Lambda, and half loop is lambda divided by 4. Okay, so that wavelength lambda which is equal to cross multiplication is 2L. Okay, and then frequency I'm writing N which is equal to V divided by lambda. Student, here V is the velocity of the transfer wave, clearly written. V which is equal to root over T divided by mu. So T represent the tension and mu represent the linear mass density. Linear mass density nothing but mass divided by length. Here V value replacing and lambda also replacing, so that V is equal root over T by mu represent the velocity of the transfer wave. Okay, so that V replacing and lambda is equal to L. Then the continuation step here, N is the fundamental frequency which is equal to V value is root over T divided by mu and divided by lambda value is 2L. So that continuation step here, N which is equal to 1 divided by 2L root over T divided by mu. Student, so this is representing equation number 2. Student, equation 2 represent the fundamental frequency of the stretched string. What is that, student? Fundamental frequency of the stretched string. See, T tension written, mu is the linear mass density given clearly. Okay, so in the fundamental frequency total 4 parameters are there. One is N is representing fundamental frequency, L representing the length of the string, T represent the tension in the string, mu represent the linear mass density. For 4 physical quantities we will get the 3 relations, student. So first relation representing between the fundamental frequency and length, and second relation represent the fundamental frequency and tension in the string, and third relation represent the fundamental frequency and linear mass density. Okay, student, so first law, that is fundamental frequency of the stretched string is inversely proportional to the length of the string when tension and linear mass densities are constant. So directly using this formula, okay, N which is equal to 1 divided by 2L root over T divided by mu. Student, from this relation, fundamental frequency is inversely proportional to the length of the string when tension and linear mass densities are constant. From this equation we will get N lambda which is equal to constant. N represent the fundamental frequency, L represent the length of the string. Student, length of the string between the two rigid support. For example, 2 times repeated this experiment with different length with different frequencies, so that we will get N1 L1 which is equal to N2 L2. Student, okay, and next one is second law. The fundamental frequency of the string is directly proportional to the square root of tension when the length and linear mass densities are constant. Already I said you. So first relation is fundamental frequency inversely proportional to length, and second relation is fundamental frequency is directly proportional to the square root of tension, student. So that n, which is equal to 1 by 2l root over t divided by mu. From this I'm writing n is directly proportional to the root t, student, because of L is constant and linear mass density is constant. So that continuation derivation n divided by root t, which is equal to constant, student, and then continuation step n1 divided by root t1, which is equal to n2 divided by root t2. Okay. And then third law, the fundamental frequency of the stretched string is inversely proportional to the square root of linear mass density when length and tensions are remains constant. So that fundamental frequency 1 by 2l root over t divided by mu, in which length and tensions are remains constant. So that I can write n inversely proportional to the root over linear mass density. From this relation n root mu, which is equal to constant. So that different frequencies we are writing different linear mass density. For example, copper wire, brass wire, steel wire using. So for that different linear mass densities are there. That's why different frequencies we will get. So finally relation n1 root mu1, which is equal to n2 root mu2. Please do like and subscribe our channel Nature of Physics.